how about having a short episode on the four fundamental forces of nature which are occurring in nature. So right now we will be discussing about the four fundamental forces which are operating in nature, and they are the first one is gravitational force of attraction, the second one is electromagnetic force, third one is strong nuclear force, and the fourth one is weak nuclear force. So before giving a discussion on these forces one by one, let me put forth a question, a jazzed up question. If I will be telling you to define nature, how are you going to define this nature? How will you define this nature? In actuality, nature around us is diverse and colorful. Sometimes it may be black and white, and in fact there are so many events that are occurring place in nature. There are so many phenomena that are taking place in this nature. So these phenomena may have the visible aspects, invisible aspects, more specifically if you will tell, mysterious aspects. So these forces govern everything what happens in nature. Whatever force you experience and even you do not realize fall under one of these. So let's give a discussion on gravitational force. What's that gravitational force? Let me tell you the statement. Any two bodies attract each other by virtue of their masses. So give me the go ahead to exemplify the same statement. So let's suppose this one is a point mass, say this a mass m1, and let's have another point mass and say it's m2. These are separated, these masses are separated by a distance r. So there will be a force of attraction between them. There will be a force of attraction. This mass will attract this mass, and this mass is going to attract this mass. Fine. Now let's consider this mass. So this mass will experience a force towards m2, because m2 is going to attract this mass. So this mass will experience a force towards m2, and let's say this is the force on m1 due to m2. This is the force on 1 due to 2. Is that clear? Now let's talk about this mass. This mass will experience a force, and this mass is getting attracted towards m1. So the force on this m2 will be this. The force on the second mass due to the first mass. So this mass apply force on this mass, and in turn this mass will apply force on this mass, and this analogy can be drawn from the Newton's third law of motion. Point points. So this is the gravitational force of attraction. So there are two bodies having masses, and these bodies will attract each other by virtue of their masses. This one is the m1 mass, and this m1 mass is going to attract this m2 mass. So this is the force on m2 due to 1, this one. Now this mass is going to attract this mass. So this one is the force on m1 due to this mass 2. Let's discuss about the magnitude of these forces. So the magnitude of these forces will be same. Point points. This is the force on 1 due to 2, and this one is the force on 2 due to 1, and if we will talking about the varying magnitude, this magnitude will be same. This magnitude will be same. And what's that magnitude? That magnitude is given by G m1 m2 divided by r square This is the magnitude. This is the this is the magnitude. Is that clear for? So these are the 2 point masses, and these point masses are separated by a distance r. So there is a force between them. There is a force of attraction between them. This mass is getting pulled by m2, and this mass is getting pulled by m1. Is that clear? And this force will be equal. Now let's talk about this g. What's that g? G is the universal gravitational constant. It's the universal constant because the value of G remains same from place to place. Is that clear? So if we will write the value of G, the value of I beg my pardon, comes to be 6.67 into 10 to the power minus 11 Newton meter square per kg square. Is that clear? So this is the value. This is the value of G. This one is the value of G. So this is one of the reasons why this force is very weak. If we will be talking about the nature of gravitational force, so this force is the weakest force is the weakest force which is operating in nature. So this one is the weakest force, gravitational force. So this is the weakest force operating in nature. This one is the weakest force operating in nature. If we will be talking about the range, this is long range force. This is long range force, and in fact it acts up to infinity. Yeah, it's quite obvious at larger distances the value of force becomes less. The force is less effective, the strength is less at larger distances. So the first one is it's the weakest force that is operating in nature, and we can say this is a long range force. If we will be talking about the medium, it doesn't require any medium. It requires no medium. It requires no medium. Clear, folks? So this is all about gravitational force. Now let's come to electromagnetic force. Right now we will be discussing about electromagnetic force. So two particles may exert upon each other electromagnetic forces. If there are two particles having charge Q1 and Q2, and which are at rest with respect to some observer, there is a force between them. There is a force between them, and this force is called Coulombic force, or you can say electrostatic force. So the force may be attractive or repulsive. That depends upon the nature of charges. Is that clear? Let's say this one is Q1. This charge is Q1. Fine. And let's say let's have another charge that is Q2. And these charges are separated by a distance r. Is that clear? Now let's say this one is positive charge and this one is positive charge. So these both are positive. So both the charges are getting repelled. This is going to repel this charge, and this one is going to repel this charge. Now let's discuss about this charge. So this charge will experience a force in this direction, and this one is the force on charge 1 due to 2. So this charge gets repelled by this Q2 charge. Now let's discuss the force on this charge. So this charge gets repelled by this charge. So this one is the force on 2 due to 1. So there is a repulsive force here, because the nature of the charges are same. Both are positive. Even if both would be negative charges, the same will happen. There will be the force of repulsion. Now let's have negative charge over here. This one is Q1, and this is positive charge Q2. So this charge will experience a force and this charge will get attracted. This charge will get attracted by this charge. So this will force the feel the force of attraction. This is going to experience the force of attraction, and this is the force on first charge. This is the Q1 charge. Force on Q1 charge due to Q2 charge. Is that clear? Now let's come to this one. This plus Q2 charge. So this will experience a force, and this is getting attracted. This will be attracted by this charge, and this is the force on 2 due to 1. Yes folks, is that clear? Now if you will be talking about the magnitude, so magnitude will be same here. Magnitude will be same here. If you will be talking about the magnitude, so magnitude will be the same here. If I will tell this one F12 equals to F21 in magnitude, so the magnitude will be same. This charge will attract this charge, and this charge is going to I beg my pardon, this charge will repel this charge, and this charge will repel this charge. Fine. This charge will repel this charge with a force, and this charge will repel this charge with the same force. Now let's come to this one. This charge will attract this charge with a force, and this charge is going to attract this charge with the same force. Is that clear folks? And the force, if you will talking about the nature of the force, that force acts along the line joining these charges. This force acts along the line joining these charges. So the value of this is called electrostatic force. This one is electrostatic force, or this one is electrostatic force, or you can say this is also called Coulombic force. So the magnitude of this Coulombic force, the magnitude of this electrostatic force is given by, this is 1 by 4 pi epsilon naught into Q1 Q2 divided by R square, and R is the separation. Is that clear? This is the magnitude of this force. So F12 will be equal to this one, and F21 will be equal to this one. If you will be talking about the magnitude, let's say this is K. In many textbooks you will find that this 1 by 4 pi epsilon naught is written as K. So right now I will be writing this one as K. So this is K Q1 Q2 by R square, and this is electrostatic force. Is that clear? And the nature of this electrostatic force depends upon the nature of the charges, whether it is repulsive or attractive. That depends upon the nature of the charges. Like charges repel each other, and like charges attract each other. Is that clear? Now this one, this K has a value here. This K has a value here. This K, or you can say 1 by 4 pi epsilon naught is K, and this K, or 1 by 4 pi epsilon naught, has a value, and this value is 9.0 into 10 to the power 9. Clear? That's Newton. If you will ask about the Newton, that's Newton meter square per Coulomb square. Newton meter square per Coulomb square. If you will compare this with this one, this is Newton meter square per kg square, because right now we are talking about the masses, and here it's Newton meter square per Coulomb square, because we are talking about the charges. So the value of K is 9.0 into 10 to the power 9. Is that clear? So let's talk about the range of this electrostatic force. So the range, it's a long range force. It's if you were talking about the range of this electrostatic force, let's say this is long range force. This is long range force. In fact, this acts up to infinite distances, and it's quite obvious at large distances the forces become weak, but it acts up to long distances. That's why it is called long range force. Is that clear, folks? At the same time, like this gravitational force, it doesn't require any medium. It requires no medium. It doesn't require any medium. And this one is the second strongest force which is operating in nature. Once again I am repeating my words. This is the second strongest force which is operating in nature. I'm just writing here. This is the second strongest force which is operating in nature, and one of the reasons behind that the value of this K, that is 9.0 into 10 to the power 9, the value is very large. Is that clear? So apart from these, electromagnetic forces may show up in many forms, such as contact force, tension force, spring force. So we will be dealing with these forces, that is contact force, spring force, in our separate videos. Is that clear, folks? So I must tell you to pause your video and just note down these steps. Yes, friend. Right now we have discussed electrostatic force, and the nature of that force depends upon the nature of charges. It's repulsive if the charges are like, and it's attractive if the charges are unlike. So electrostatic force, we discussed about electrostatic force. One thing about electrostatic force I want to draw it out, that the charges should be at rest with respect to some observer. The charges should be at rest. Clear? The force which I have discussed right now, that is K into Q1 Q2 by R square, that is the electrostatic force, and this is given when the charges are at rest with respect to some observer. We have not discussed about the force when the force between the moving charge, when the charges are in motion. We haven't discussed about that force because that one is very complicated and it contains phenomena other than the Coulombic force. Clear? Now let's come to strong nuclear force. Fine, folks. Strong nuclear force. What's that strong nuclear force? I hope that, the video is too long, so I will be continuing this one. This is a strong nuclear force and the weak nuclear force in my next video, because this video is too long. So just watch my next video. In that video I am going to give the details about strong nuclear force and weak nuclear force. Clear, folks? Thank you.